This says, given that the eccentricity of the ellipse is 4/5 and the foci lies on the point, points plus 3 halves, 0, and negative 3 halves, 0. What is the equation of this ellipse? Okay, this didn't actually finish out, but we're going to find the equation of this here ellipse. Well, let's think about some stuff. We know that E is equal to C over A. Correct? So E is equal to C over A. That says the eccentricity is a C value divided by your A value. Okay? Now, we do know what the foci is. We know that the foci, especially since this here lies on the, since this here is at center 0, 0, so let's write that here, may be helpful to us later, is equal to 0, 0. Okay? So since we know that the formula for the foci is just C, let me rewrite that. It's just C, 0. Plus or minus C, 0, of course. We know that's true. So that must mean that 3 halves is equal to C. Well, if I know 3 halves is equal to C, I can say E is equal to 3 halves divided by A. Okay? Well, what is 3 halves divided by A? That's going to be the eccentricity, which is 4/5. So now I've set up a proportion or an equation, if you will. So let's go ahead and solve this equation for A. We cross multiply, we'll get 4A is equal to 15 over 2. Multiplying both sides by 2 to get rid of this here fraction, I'll end up with this answer here, 8. Okay, just to save space, we're not going to write that step out. You guys should be advanced enough to understand this. So I'll multiply, of course, like I said, I'll get 4 times A is equal to, what is this, 15 divided by 2. Okay, and I will be left with this here. I'll be left with A is equivalent to 15 over 8. Okay. Now that I have A is equal to 15 over 8, all I need for my equation is my B value, because I have my C value and I have my A. Now, I need B. That's what I really need. I don't necessarily need C to find the equation, but it can help. C is something that can help me. This is called using what you have to find out what you don't have. Okay? So we're going to take that approach there. Well, what do we know about the relationship in these three variables here? Well, we know that C squared is equal to A squared minus B squared. Now, we want B. To make it easier for us when we actually have numbers in here, let's go ahead and solve for this equation for B. So let's go ahead and add B to both sides here. B squared to both sides. These will cancel. I'll be left with B squared plus C squared is equal to A squared. Okay? So B squared plus C squared should be equal to A squared based on me solving this here. Okay? So it says B squared plus C squared should be equal to A squared. So we need to save space here. So that said B squared plus C squared is equal to A squared. Okay, well, what is B? That's what we're going to find out. So we'll bring that down. Now, what's C? Well, C is equal to 3 halves. 3 halves squared would be 9/4. Now, this is equal to A squared. Well, we said A is 15 over 8, which will be 15 over 8 squared will be 225 divided by 64. Because 15 squared is 225 and 8 squared is 64. Okay? Now, what do we do from here? Well, let's subtract 9/4 from both sides. These here will cancel, and I'm left with B squared is equal to 225 over 64 minus 9 over 4. Which this value here, let me scroll down, this will be 81 over 64. Now to find B, we can just get the square root of both sides, but if you remember for this equation here, we actually need B squared, so it'd be irrelevant for us to actually find B. So we can just leave it in the form of saying B squared is equal to 81 divided by 64. Okay? Now, what is the equation of this? Well, we said the center is already at 0, 0, so that tells us we're going to have this equation here. x squared divided by a squared plus y squared divided by b squared is equal to 1. Now, the only problem here that we'll have is determining if it's going to lie, if this ellipse is actually on the x-axis or if the ellipse is on the y-axis, the major axes. What axis is it on, the x or the y-axis, the major axis of this here ellipse? Well, since we have a 0 here in my y value, this tells us that we didn't go up any in a y direction. So we're going to say that y actually didn't change. So that means this major axis actually lies along the lies along the axis of y. The axis of x. So we're going to use this here equation. Now, what is x squared? Well, let's go ahead and figure this stuff out here. Okay, well let's go ahead and substitute in for here. Well, we'll have x squared divided by a squared. What's a squared? Well, 15 over 8 squared, that'll be 225 over 64 plus y squared over b squared. Well, what's b squared? B squared is 81, which we said here is 81 over 64. Okay, make that look more like a 4. Okay, 81 over 64. Now that we have this here, this is in complex fraction form. We don't want to leave stuff in complex fraction form. It just looks really messy that way. So we're going to go ahead and simplify this as much as we can. Let's use a different color to simplify it. Okay. Well, of course, you know, complex fractions, this will be here x squared times 64 over 225 plus y squared multiplied times 64 over 81. Okay, and this whole thing is equal to 1, of course. And I'll end up with 64x squared divided by 225 plus 64y squared divided by 81. And this is equal to 1. And this is actually in standard form. Okay? This would be actually the standard form of this ellipse. Standard form of the ellipse here. Okay, so basically in this video, just to recap here, we were given the eccentricity and we were given the foci, and we found our equation. And from this equation, we can do a lot. We can graph it. We can determine. If you want it, we can plot its foci on here. We can do whatever. And given this eccentricity, 4/5, we can actually determine if this will be more oval shape or this will be more circular shape. And based on this here, this will be a lot more circular shaped than. This will be a lot more oval. This will be a lot more oval shaped than it will be circle shaped. Okay, because 4/5 is a lot closer to 1. Okay, than it is 0. All right.